Good morning and welcome to my presentation. So it is on environmental vulnerability and adaptation to global climate change. I'll be going a little bit slowly so that you can catch up. Myself, I'm Maruthi Balaji Bhaskar. I am from Texas Southern University. Next slide, please. Starting with my first slide is about the definitions for weather, climate change, and natural vulnerability. So when you say the weather is a short-term event, which is a day-to-day changes in the climate. Climate, when you talk about climate is the long-term. It involves all the averages and statistics. So it is a long-term change of like multiple of years. So how the temperature pattern is changing or the rainfall pattern is changing, that we'll call it as a climate. So the difference between weather and climate is climate is a long-term event, weather is a short-term event. So when we say climate change, it refers to the long-term shifts in this pattern of the climate. So whether it is a rainfall event or the hurricane events or the temperature, so how it is going to change during course of time. The climate change can be affected by the natural vulnerability or natural variability, how it changes due to the natural events during the course of the time. The second thing is it can also be changed by the man-made events or anthropogenic causes. Next slide. So when you say anthropogenic events, the human activities links humans to the Earth's natural systems, making climate change more complex. So to how to reduce the climate change, we can actually talk about like a mitigation. Mitigation is actions that reduces the sources of gases which contribute to the warming of the climate system. So the climate change is happening because of the greenhouse gases, what we are emitting. It involves the carbon dioxide, water vapor, chlorofluorocarbons, methane, and so on. So all these greenhouse gases, what contributes together is called as the greenhouse gases. So it involves a big list. Next slide. So adaptation is, so to combat the climate change, we can actually talk about the adaptation. So adaptation is the adjustment of the natural or human systems to actual or expected climate stimuli or their effects, which moderates harm or exploits the beneficial opportunities. So the climate change actually heightens these vulnerabilities of societies and ecosystems. The second thing is sustainability. So how to combat this climate change is by adapting for the sustainable mechanisms. So one way to meet the sustainability is capacity to meet the needs of the present without compromising the ability of future generation to meet their own needs. So we'll be keeping on with the development. At the same time, we'll be using the carbon sequestration methods and so on, so that we'll not be altering the climate at a very fast pace. Next slide. So when you talk about the climate change paradigm, so here you're having all these natural events. So in this case, the water cycle, the carbon cycle, these are all the natural events which happen during the course of the time. Hundreds of years these are happening. So into this equation, you can add the anthropogenic change or human change. So with the build-up of the industries and the build-up of the bigger cities, what you are seeing is there's a lot of human contribution, which involves all these greenhouse gases. So you're having carbon dioxide, methane, nitrous oxides, ozone, chlorofluorocarbons. So once you have a lot of greenhouse gases, what you're seeing is there is an increase in the climate change impacts. So it can be the rise in temperature and so on. So for that, to see whether the climate change is happening, so in case of the scientists, we depend on the data. So in case of the climate science, there's a lot of data. You can actually go back to almost 100 years, and we are continuously taking a lot of data. So it can be the temperature. So you can see here the temperature of the land, the sea. So all these air temperatures are increasing during the course of the last 100 years. All these things, you are actually seeing a slope, so showing an increase in the temperature for the last 100 years or more. And you can also see here the the summer Arctic ice is reducing. So you can actually see an increase in the temperature and the Arctic ice is reducing. And that is all the scientific data, which is all available. We can actually download the data. You can actually see the data, which is a solid evidence, because science believes in the data. Next slide. So one particular parameter is the greenhouse gas. So when you look at here, this is all the carbon dioxide. So during the course of hundreds of years, you can see the carbon dioxide is all below 400 ppm. So during the course of the last 20 to 30 years, we actually break that glass ceiling, so we almost hit the 400 ppm. So with the increase, and we are above the 400 ppm now. So with the increase in the carbon dioxide, so with the increase in the greenhouse gases, we're actually seeing a lot of the global warming or a greenhouse effect, where you are seeing increase in temperature, as a result of which you have a lot of catastrophic events based on that. So this is one greenhouse gas. In the same fashion, you can actually see an increase in greenhouse gas for the methane, the water vapor, and the ozone, and so on. Next slide. So here you can actually see the picture here for the thousands of years. You are actually seeing all the greenhouse gas was below 300 ppm. So during the course of the last couple of years, we actually saw a shoot in the carbon dioxide, where actually here we crossed the 400 ppm. And if we don't stop this carbon dioxide, so what will happen? So one can be, there can be increase in the temperature. So there can be heat stress on people and crops, or there can be a sea level rise, more floods and droughts, stronger storms can grow stronger. So during this year itself, within US, we saw Harvey, we saw Irma, we saw Maria, all are like category 4 storms. So we are seeing those events. So tropical diseases no longer frozen. So once the temperature increases, you can actually see more tropical diseases even in the temperate countries. So we are seeing the spread of Zika virus and so on. Ecological stresses and extinctions, losses, especially for poor people in hot places who release little carbon dioxide. So those are all the events which will happen if the carbon dioxide keeps on increasing. Next slide. So where is this global warming happening? In which place? So when you look at the entire globe, entire Earth, oceans are the ones which are absorbing a lot of heat. So the oceans are heating up fast. So followed by the oceans, you have the atmosphere, continents, glaciers, and so on. So once the oceans warm up, so you are actually seeing a change in the effect on the coral bleaching, or whatever the hurricanes that are coming, they are becoming more stronger, and so on. And it can impact also the fishes and the food production. Next slide. So the climate tipping points, so whatever these climate change effects are there, it is not at a regional area. So the impacts can be global, so it is affecting all the different areas. On the top, you are actually seeing, this is the real time, which you can actually see on the NASA website. So you can see the carbon dioxide right now is about 406 ppm. The temperature increased in the last 100 years, 1.7. Arctic sea ice, what you're seeing is minimum. Land ice is again the minimum. Within the United States, so when we look at the data for the last probably 50 to 60 years, we can actually see the tornadoes got increased during the course of the time. So whatever the tornadoes you are getting, there are multiple tornadoes, and they are getting more stronger. Next. And same is the cyclones, tropical cyclones and hurricanes. So during the course of the last 100 years, this is all the data what is there, because in the science we believe in the data. So with the data, you can actually see the intensity of the hurricanes is increasing during the course of the time. So what happens? So what can be the impacts? So the tomorrow's climate problems include, because as the population became like 7 billion people right now, and most of these mega cities around the world. Mega city is any city which is having more than 10 million people, that is called as a mega city. So you can see all the mega cities are all near the oceans or near the beaches. So during the course of the time, you're having a lot of people living along the seaside, and you're seeing a sea level rise. So there's a lot of vulnerable people. So there is a rising sea level. The coastal mega cities are going to be impacted by that. Next slide. So tomorrow's climate problem includes, so when you look at all the different crops, with the increase in the carbon dioxide, with the increase in the temperature, what you are going to see is the alfalfa production, safflower, maize. So most of the crops, the production, the yield will reduce with the increase in the temperature and high carbon dioxide. So and also when you look at the fisheries, so most of the fisheries are getting depleted because the oceans are becoming hotter, the corals are bleaching, so the fisheries production is reducing. So that means there is an impact on the yield, the reduced crop yields, and also the reduction in fisheries throughout the world. Next slide. So because of the climate change, there can also be a lot of social implications. So once there is a reduced amount of the food production or reduced food available for the entire world, you can actually see a lot of global conflicts. You can also see there is a relationship between the temperature and the conflicts. So if the temperature increases, so we have the data to show there's a lot of increase in the violence also. The more the temperature, there is a more unrest. Next. So which countries are releasing more greenhouse gases? So whatever you see, all the countries in the red, all the developed countries, most of the Europe, most of the North America and Canada, or Australia, these are the countries releasing a lot of greenhouse gases because more carbon dioxide and methane and so on. But who are impacted? So all these areas, all the developing countries are impacted more. Because once you have an increase in the greenhouse gas or the increase in the methane, what you are seeing is an increase in temperature and a reduced food production. So once there is a reduced in food production or reduced in the yield, which countries are affected? It's mostly the developing countries, because the developing countries struggle from time to time for the food and all those things. So the producers are least impacted, and the people who are producing less are going to be impacted more. So, so population and energy usage are closely related. As you have more and more people, so there is a more use of energy. So it can be fossil fuels, petroleum, natural gas. So when you look at here, we are actually depending more on the oil, coal, and gas for our energy. So here you can actually see most of our energy comes from the coal and natural gas, very less from the renewable resources like the hydro, solar power, the biomass, or biofuel, we are getting very less. So to adapt to this climate change, we need to adapt more on the renewable resources so that we can actually reduce our dependency on the coal and natural gases, so that we can actually reduce the impact of the climate change into the future. Next slide. So how we can actually mitigate or reduce? So by producing more energy from the solar power. So there are different ways. So one mechanism is concentrating solar power, where you have the multiple solar panels so that you can actually beam all the light to one source, and then you can actually produce more amount of energy. Or you can have more wind farms available. So you can make more wind farms. So all these energy resources are the zero carbon productivity, so you can actually have no impact, no negative impact on the climate by the renewable resources. So there is a one graph developed by National Renewable Energy Lab. So here, when you think of all the harvesting all the renewable energy resources, so the biomass, wind, the solar energy, you can actually completely supply the power for the entire US. So if we can actually do that for the one country, so all the rest of the countries actually use less amount of energy than the United States. So that is definitely achievable, or it can be done. Only thing is we need more commitment and more policies to support the renewable energy. Excellent. So in conclusion, the global warming is real. Human activity is responsible for a large majority of warming since about the 20th century. Human reliance on fossil fuels is at the heart of the anthropogenic climate change. So once we can actually reduce our dependence on the fossil fuels and go for the renewable resources, so there is definitely a way for the adaptation for this climate change. Mitigation seeks cut emissions via cap and trade, carbon capture and storage, higher energy efficiency in generation. Adaptation makes communities more resilient. Skepticism in science is healthy, so we have a lot of skeptics denying the climate change. But in science, we believe in data. The data strongly shows there is an increase in all these different parameters of the greenhouse gases, and it is real, it is happening. So the hope is that with greater education like this, so we can actually make a change. Next slide. So here is one particular example. We can actually bring stronger levees. I think this one is from the Hurricane Gustav. This is in New Orleans. You can actually see all these areas got inundated, and the police officer is actually picking there. So looking at how much water level is there. So you need to, during the course of the adaptation, probably we need to make sure whatever our big cities are there, we need to probably build it more inland. So not towards the seashores, because as the sea level increases, there can be, all these cities will be impacted by that, or we need to make stronger levees or more efficient pumping mechanisms or so. Next. This is the recent event which happened in my hometown, which is in Houston, Texas. So we had Hurricane Harvey came in on September 1st. We got 50 inches of rainfall. So we measured the rainfall in feet. So after 50 inches of rainfall, you can actually see a lot of the roads, everything got inundated. And this is my current research going on. So this is before Harvey. So this, my home is somewhere here. So this is my county. So you can actually see this particular river is the Brazos River. During the course of the Hurricane Harvey, the river swollen and it occupied the entire county. And you can actually see a lot of houses, a lot of communities, everything got inundated. So there's a lot of property damage and so on. Next slide. And this is after the Hurricane Harvey, you have a lot of sediment, everything went into the Galveston Bay. So this is before Harvey, and this is after Harvey. So after 4-day rain event, the storm stopped. So you have a lot of sediment went into the Galveston Bay. The Galveston Bay is rich in a lot of oysters. So oysters are filter feeders. So most of our oyster industry was impacted by the Harvey. So we have completely decimated the oyster industry because of that. So you have a lot of the sediment, so there's a huge impact of the Harvey on that. Next slide. So I can leave it here. So by adapting for the renewable resources, so one mechanism is also this one, flying solar carpets. So probably you can have a flying solar carpet so that it can actually beam the energy back. So that is one idea there. And with the renewable resources, there is a stronger economy, there can be more jobs, and there is a cleaner environment, and that is clearly a path for adaptation for this climate change. Thank you.